Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be going over equation stoichiometry, or what is also known as just stoichiometry. So let's get into this. So stoichiometry is basically a method by which you use a balanced equation to find the amount of substance that you need from a given amount of another substance, right? So let's say I'm given a certain amount of a reactant and I want to know, well, how much of this other reactant do I need to react completely with the amount of the first reactant that I'm given, right? Or another example would be, what if I'm given a certain amount of reactant and I want to know, well, how much possible product, what's the maximum amount of product I could form from this reactant given this balanced equation? And so that is stoichiometry. So what I want to go over in this video is kind of like the steps, the method by which you are going to solve stoichiometry problems. So let's get started. Okay, so what I have here is a sort of roadmap that you should follow whenever you're given a stoichiometry equation. Now, the dead giveaway that you've got a stoichiometry problem is that you're given a balanced equation, or you need a balanced equation in order to convert from one substance in a reaction to a different substance in a reaction. So you've got a reaction going on, and you've got to go from one substance to another substance in the reaction. So you're going to need a balanced equation for that. Okay, so either you're given the balanced equation or you need to come up with the equation and balance it yourself. Either way, you're going to need that balanced equation to do this process. Okay, so in every problem, you're given some sort of unit to start with. So in this video, I'm going to be focusing more on mass conversions. So normally you're given some sort of mass of a given substance, a reactant or a product, and you're asked to find the mass of a different reactant or product, right? So you're going to be given some unit, right? So right off the bat, the way I want to break this down is in three basic steps. I know you see a bunch of steps here, but you can categorize this into three basic steps. The first step is to convert whatever unit you're given, convert to moles, get to moles. That is your first goal, right? So your first major goal is to convert whatever unit of the substance you're given to moles. And that goes for any problem you're given, not just mass, but if you're given liters of a gas or liters of a solution or whatever the case may be, or you're given, I don't know, grams or kilograms, whatever the case may be, you need to convert that unit of that substance to moles. That's step one. Step two, as soon as you get to moles, you're then going to use a mole ratio to convert from moles of one substance to moles of the other. Now, in a previous video, when we were talking about going from the element in a compound to the compound, or from the compound to the element in the compound, we were using the mole ratio from the balanced equation. I'm sorry, not the balanced equation, the formula, right? So, for example, H2O. If I wanted to go from the amount of water, H2O, to the amount of hydrogen, then I would use the 2-to-1 ratio in the equation between hydrogen and water. And I would use that mole ratio to convert from moles of one substance to moles of the other. So in that video, we talked about how you could use the formula to get your mole ratio. But in equation stoichiometry, you're going to use the balanced equation here to get your mole ratio, right? So if you remember, in a balanced equation, it's giving you the moles or molecules of one substance to another. So here I can read this as 4 atoms of phosphorus will react with 5 molecules of oxygen to produce 1 molecule of P4O10 or tetraphosphorus dicoxide. Okay, so that is one way to read this. The other way to read this is by moles. So I can treat the coefficients as moles. So 4 moles of phosphorus plus 5 moles of oxygen will give me 1 mole of the tetraphosphorus dicoxide. Okay, so I can get my mole ratio directly from the coefficients. So if I wanted to convert a given amount of phosphorus to a given amount of oxygen, I would use the 4 to 5 mole ratio, 4 moles of phosphorus to 5 moles of oxygen. Or if I wanted to convert moles, I wanted to convert a given amount of phosphorus to a given amount of the tetraphosphorus dicoxide, then I would use the 4 to 1 mole ratio. So that is the second step. Use the mole ratio to convert from moles of substance 1 to moles of substance 2. And then finally, step 3, once you get the moles of your substance to whatever that substance is, convert that to whatever unit you desire. So if there's a particular unit that you're supposed to get to in the problem, convert to that unit using whatever conversion factors you need at your disposal. Okay, so those are the 3 steps. Unit of substance 1, convert that to moles. Convert moles of substance 1 to moles of substance 2 using the mole ratio. And then convert moles of substance 2 to whatever the desired unit is in the problem. That's step 3. Okay, so that's the general idea. So here it's broken up into more steps, but it's still the 3 basic steps. So here I'm given units of whatever substance 1. So if it's mass, which I'm going to be focusing on in mass, it could be kilograms, it could be milligrams, it could be micrograms, nanograms, whatever the case would be. But you're given a unit of substance 1. If it's not grams, then the first step is to convert that unit to grams, right? So if I'm given kilograms of substance 1, well, if I'm going to get to moles, I need to use mole ratio. I'm going to need to use the molar mass, right? Because if I have a mass and then I want to get to moles, the way to do that is through the molar mass of that substance, because the molar mass gives you a relationship between the grams and the moles of that substance. So if I'm not given grams, I need to convert to grams first. That's my first step. So whatever unit of the substance 1, you're going to use analysis conversion factors to convert to grams, right? So if I'm given kilograms, then I'm going to use the conversion factor that 1 kilogram is equal to 1,000 grams. That's a relationship I can use to convert to grams, right? If I'm given milligrams, then I'm going to use 1 gram is equal to 1,000 milligrams, or 1 milligram is equal to 10 to the third, or 1/1000th of a gram. So either way, I'm going to use a conversion factor to convert to grams. Once I get to grams of substance 1, then I'm going to use the molar mass of substance 1 to convert grams to moles. Now I've got moles of substance 1. So step 1, that general step, that first step is done. Now, to convert from moles of substance 1 to moles of substance 2, I'm going to use the mole ratio that was derived from the coefficients in the balanced equation. So again, the coefficients in the balanced equation, 4, 5, 1, I'm going to use whatever the coefficients are for the substances I'm converting between, right? Substance 1, substance 2, whatever they are. So I'm going to go to my balanced equation, and I'm going to get that mole ratio. I'm going to use that as a conversion factor to convert from one substance in moles to the other substance in moles. So that's step 2. And then step 3, again, is once I get moles of the substance 2, I'm converting that to whatever unit that they want, and I'm going to use whatever conversion factors that are at my disposal. But the first thing you want to do is convert to grams, right? Because again, we're assuming we're going from mass of one substance, mass to the other substance. It's a mass-mass conversion. So in this case, I want to get to grams. So I need to get to a mass unit. So I'm going to use the molar mass. So now I'm using the molar mass of substance 2 to convert to grams of substance 2. And then once I am here with grams, then I will convert that to whatever the desired unit is. Again, if it's kilograms, I'll use the conversion factor between kilograms and grams to convert to kilograms. If it's milligrams, I'll use the grams to milligrams conversion or whatever metric conversion that I need to use. Okay, or if they want pounds, I'll convert it to pounds, or ounces, I'll convert it to ounces. But whatever unit they want, I'm going to use conversion factors to get to that unit. Okay, so I hope that's clear. So with that out of the way, I hope this is a good explanation of my roadmap. So now I'm going to give you an example of how to use this roadmap. So here I have this balanced equation where phosphorus reacts with oxygen to give me tetraphosphorus decoxide. And so in this problem, they're giving me 1.09 times 10 to the 4 kilograms of phosphorus. And they want to know, well, how many kilograms maximum can I get from this amount of phosphorus? Well, they're giving me kilograms of one thing. I need to get the kilograms of the other thing. So I'm going to use the roadmap. So I get kilograms. First step is get to grams. So how am I going to do that? I'm going to use the metric conversion factor that I need. So let's start. We always start by writing the substance that we have. So we're starting with phosphorus. So I have 1.09 times 10 to the 4 kilograms of phosphorus. And notice that when I'm doing my conversions, I always have three things in my number here, in my setup. So the first is the number, second is the unit kilograms, and the third is the substance I am dealing with, in this case, phosphorus. The reason that I write all three is because I'm going to be converting to a different substance, and I need to make sure that I keep track of what substance I'm talking about during the process. If I do not write the substance, then the number, I could get easily confused about what substance I'm talking about. Okay, so here, I got 1.09 times 10 to the 4 kilograms of phosphorus. First step is I need to convert that to grams. So I need to use the relationship between kilograms and grams. I'm going to use that as conversion factor. So I have kilograms on top. I want kilograms on the bottom. So I'm going to put 1 kilogram on the bottom because I know 1 kilogram is equal to 1,000 grams. So 1 kilogram of what? Phosphorus. Okay, now that I got that out of the way, so now on top, I'm going to have 1,000 grams of phosphorus. So since I got kilograms of phosphorus on the top and the bottom, that is going to cancel out. So now I have phosphorus. So I'm done with step one. I've got grams of phosphorus. So this first step is done. Now I'm going to use the molar mass of phosphorus to convert phosphorus to moles. So I'm going to go from grams to moles using the molar mass of phosphorus. So let me look that up. And that's going to be 9738. So 1 mole of phosphorus is going to be equal to 30.9738 grams. So let me just double check that again, 30.9738. So since I have grams of phosphorus on the top, I'm going to put 30.9738 grams of phosphorus on the bottom and 1 mole of phosphorus on top. So now the grams of phosphorus will cancel out because I have top and bottom. And now I have moles of phosphorus. So look where I'm at now. So I've converted grams to moles. Now I have moles of substance 1, which is phosphorus. So now I can do the mole ratio from the balanced equation. So I'm interested in going from here to here. So these are the two substances I'm interested in. So the mole ratio between phosphorus and tetraphosphorus dicoxide is 4:1. So 4 moles of phosphorus will give me 1 mole of the tetraphosphorus dicoxide. So I'm going to use that as a conversion factor to convert from moles of phosphorus to moles of the tetraphosphorus dicoxide. So I'm going to continue down here. So I have moles of phosphorus on the top. So I'm going to put 4 moles of phosphorus on the bottom to cancel out with moles on top. And then I'm going to have 1 mole of the tetraphosphorus dicoxide on top. So moles of the phosphorus on top will cancel out with the moles of phosphorus on the bottom. And now I have moles of the tetraphosphorus dicoxide, which is my substance 2. So now I've done my conversion from moles of substance 1 to substance 2. Now I'm here. Now the third and final goal is to just convert to the unit that I need to convert to, whatever they're asking me to convert to. In this case, they're asking me to convert to kilograms of this substance. So I need to get to kilograms. I have moles. The first step has to be going to grams because I need to get to a mass, and the only way I can go from moles to mass is through the molar mass, right? So I can get to grams. So now I'm going to use the molar mass of the tetraphosphorus dicoxide to convert to grams. So when I look that up, I get 283 point, I believe it's 88. 889 grams. So 889 grams of the P4O10. And notice I have grams on the top because on the bottom I need 1 mole of the P4O10. So now I have moles of P4O10 on the top and bottom. So that's going to cancel out. And now I have grams of substance 2, which is my P4O10. So I've done this step. And now my final step is to convert from grams to whatever the desired unit is. In this case, kilograms. So basically I'm going to use this relationship again to convert from this time grams to kilograms. And so I have grams on the bottom. So this time I'm going to put 1,000 grams of P4O10 on the bottom because I have grams of P4O10 on the top here. I want that to cancel out. And now I'm going to put 1 kilogram of P4O10 on the top. So grams cancel out. Now I have, let me fix this, get this, there we go. So now I have kilograms on the top of my substance. So kilograms of P4O10, that's exactly what I want. As soon as you get the unit you want, you're done. No more conversions. So we're going to have an equal sign here. Turn this so you can see my equal sign. So now all I need to do is multiply across by everything on the top, divide by everything on the bottom, and I get my answer. And when I do that, I get 2.50 times 10 to, I believe it's the 4th kilograms of the tetraphosphorus dicoxide. And that's how you can use the roadmap to convert from one substance in a balanced equation to a completely different substance in the balanced equation. So this is a very useful, and you must use this roadmap to get through an equation stoichiometry problem. So I hope this is helpful. If this was helpful in any way, if you enjoyed this video, then please like the video, share the video with your friends and family. It's the Christmas season. Give it to them as a gift. Also, make sure that you hit that like button right there. And finally, well, not finally, but subscribe to my channel. Hit that notification bell. And when you do, click that all button. And so that way you're notified by all the videos I put out. And finally, put a comment down below in the comment section for me. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you have a problem or a question you need help on and would like me to help you answer that question or problem, please put it down below so that I can help you. I would love to do that for you. Thanks for joining me and have a great day.